We're going to be considering the dangers of using the JavaScript eval function and how in this particular lab it causes a possible DOM-based cross-site scripting attack. Now, this particular lab has a few moving parts, so let's just get a feel for the intended functionality of this lab first of all. So we have a blog, we have the ability to search the blog. So let's start by injecting an arbitrary search string. And straight away, we can see our search string reflected to the page. So let's fire up the DOM. Let's search for our injected search string in the DOM. We'll see where it appears. In this case, we get one match on our string, and it's appearing inside h1 tags, but it's not appearing anywhere else in the DOM. So the first obvious question is, how did it get there? There's a little bit of a clue in the lab title. Since this is a DOM-based XSS, it usually means that this particular string was injected into the DOM by a specific JavaScript sync. So the obvious question is, where is the JavaScript that's placing that particular string in the DOM? Now, this is a slight upgrade in complexity over previous labs at Burp Academy, where we might just have a single HTML page and then a snippet of JavaScript at the bottom of the page. But this particular lab makes use of a few different pages. For example, in this case, the JavaScript is actually in an external JavaScript file. In fact, we can see it on the page here, script source equals, we have this search results.js. Also, if we check out the network tab, we can see the various files that are being pulled in to make this page possible. Now we're going to jump straight to the search results.js because we want to get a feel for the logic of this page. Let's have a look at the response. Now, in some ways, this is slightly more realistic in the sense that JavaScript is usually not in the same document as the main page itself. Having said that, it's still fairly straightforward in the sense that this JavaScript has not been obfuscated. It's in a really straightforward, readable format. So let's get a feel for what's happening here. Now, we can see a function being declared here, and the name of the function is search, and it takes in a param path. And if we just head back to the DOM inspector, just like to point out that we can see that the JavaScript is actually calling this particular function, and it's passing in search results. Remember that we've just seen that this function accepts a path parameter, so we can see here the path provided as a string. The key takeaway here is that the page is calling this search function, so that's going to trigger our JavaScript. Let's head back to our JavaScript file. So firstly, we see a new variable being created. It's called XHR, and it's being assigned to a built-in JavaScript object known as the XML HTTP request. Now, we don't see these as much in modern JavaScript because they've been replaced in a lot of cases by promises, but the functionality is still the same. It allows us to make an asynchronous request to an external resource. This is sometimes referred to as AJAX, which stands for Asynchronous JavaScript and XML. Part of the irony is even when AJAX is used, it often doesn't involve XML. It often involves JSON rather than XML, as is the case in this lab, but for whatever reason, it's still referred to as XML. Before JSON became very widespread, XML was often used for communicating between processes on a web app, whereas most cases we make use of JSON, but there's still some XML being used on production websites. So this XHR object is created. We then bind a function to an event listener. So we have this event listener on.readystatechange. And the idea is that the XHR object has this ready state property, which indicates the state of the request. And the key piece of information we need right now is that ready state 4 means the request is completed. So every time that ready state changes, this function is triggered. It checks to see if the ready state is 4 and also if the HTTP response status is 200. If both of those are true, it means the HTTP request has succeeded and we can access the response data by making use of this .response text. In order to initiate this HTTP request, we then need to make use of the .open method, provide some parameters. So this is going to be the path that was provided through the path parameter from the original HTML document plus window.location.search, which is going to be anything after the query string. Then finally, we call the xhr.send method, which is going to dispatch the HTTP request. So now let's return to this event handler. Let's pretend we've dispatched our HTTP request with the search information. We've now received a response. What is this JavaScript doing with the response? It's calling eval. It's passing var search results obj equals as part of a string. Then it's concatenating to that string this dot response text. Finally, it's taking the newly created search results object and it's passing it to a second function, which is defined below, called display search results. Now let's just focus on this line of code, eval, and then we can see that a string is passed to the eval function. What is the JavaScript eval function? Here we can see a description of eval in JavaScript. The eval function evaluates JavaScript code represented as a string and returns its completion value. Then notice we have a warning in red. Warning, executing JavaScript from a string is an enormous security risk. It's far too easy for a bad actor to run arbitrary code when you use eval. So this is something that works in JavaScript, but it's saying don't use eval. It's very dangerous. It poses huge security risks. Now we'll come back to this shortly and see what the problem is with that eval code. First of all, let's just refresh this page. So we're going to be submitting the same search term because it's contained within the query string. And let's just follow the lab through. So we know that that search function is called. As a result, that XHR object is created. Then we expect an AJAX HTTP request to be sent to search results, and we can see it here. So if we check out the headers tab here, we can see a GET request made to our Academy /search results. Then part of the query string, we see our search term, search equals Zenshell. Let's have a look at the response. So the response here is a JSON object. So we have our first key, which is called results, and an empty array. That's because we don't have any matches. Then we have a second key, which actually mirrors back our search term to us. So we have a search term key as part of this JSON object, and it tells us your search term was Zenshell. And obviously that Zenshell term is then taken and reflected to the page. And if we dig around in that JavaScript, we should be able to see that. So keep in mind that we have a JSON response, which is stored in this.response.text. That JSON has been bound to our variable search results object that's passed to display search results. And what this display search results does is it basically goes through the DOM and renders all of our search results to the page. But we're not too interested in that for now because the vulnerability actually occurs before all of that information is rendered to the DOM. Let's take a look at that AJAX HTTP request that's sent to the search results endpoint, which returns the JSON object. So we can see that HTTP request here, and we can see the JSON response. So we have an empty array for results because our search term didn't return any results. We then have this search term key with Zenshell. Now we're going to jump ahead and say that it's possible to break out of this string. So we can actually break out of this Zenshell string and we can add an alert function, or we can subtract in this case. So let's experiment with our input. We can right click and choose send to repeater in Burp. So this is the request that we're going to send. In fact, let's just submit that and we see our JSON response. Now the obvious way of attempting to break out of the string is simply to include a double quote. Then we could do something like -alert. And the reason why we like to use minus instead of plus is simply because plus is typically URL encoded, whereas minus or hyphen is not. So rather than Zenshell plus alert, it's typical to try something like Zenshell minus alert. It's a little bit cleaner this way. Let's send that and see what we get. Now, what we can see is we failed to break out of the string, and that's because the JSON response is automatically escaping that double quote. So this is a standard feature of JavaScript strings. Imagine we wanted to create a string with double quotes, but we wanted a double quote character inside that string, but we don't want that double quote character to terminate the string as it would ordinarily. We can make use of what's known as escaping. In JavaScript, it means placing a backslash before that particular character so that character no longer carries its special meaning. So you can see what's happening here is that because there's a backslash before that double quote, it's not terminating the string. The interesting thing though is that backslash is also a special character that can be escaped. So if we instead put backslash double quote and submit that payload, see what we get. Well, now we've actually broken out of that JavaScript string. You see the backslash returned from the JSON response is no longer escaping that double quote because we're escaping it manually with the backslash we're submitting as part of the payload. So what we actually have here is search term Zen shell minus alert. Now, part of the problem is that we don't have a valid JavaScript object at this stage. That's because we have this trailing quote and we have this end of the object. We can actually comment that out. And the way we use comments in JavaScript, // but we're going to end our JavaScript object first, and we're going to submit that. So what we have now is completely valid JavaScript object. So we have search term, we have a string minus the alert function. Our object ends correctly. We then have the JavaScript comment characters, and then that isolated double quote is commented out. So let's take this now as our payload. So we're going to copy this. We'll head back to our lab. Let's paste this into our search box. And you can see we get the alert function popped up to the screen. So this is the lab solved, but the question is, why is it working? Because surely we can't ordinarily just comment things out on a JavaScript object. But the thing is, this is not a pure JavaScript object. It's actually constructed from a string. And this is where we loop back to that eval function causing us problems. I think the best way is to just recreate the lab. So we're going to create a fresh HTML document. We're going to put everything inside HTML tags. We'll have a body to our HTML document. We'll just give it a heading. We're going to call it eval because really this is a lab on why you should never use eval. I'll place an empty paragraph after the H1. And this is actually not part of the exploit, as you'll see. This is what happens after the exploit, because the lab actually renders the search results to the page. In fact, it creates the element first, then places the text in that element, then attaches it to the DOM. We're not going to do all of that. We're just going to place the element automatically in the HTML, but we will have to render the search results to the page. So let's open up some script tags so we can make use of this XHR JavaScript functionality we were referring to. So we can say var XML HTTP equals new XML HTTP request. We'll then specify the URL for this HTTP request. And you can see I've created a data.json and it has inside information Zen shell. And we'll start a web server at port 8000. So in order to get this JSON object returned as a response, we'll say var URL equals http /localhost at port 8000. Then of course we can reference the name of the file directly, which is data.json in this case. So now we need to set up the event listener. So we can say XML HTTP on.readystatechange equals, we'll code our listener now. And we can say if this.readystate equals exactly 4 and this.status equals exactly 200. That means that the HTTP request has succeeded. So this is going to be our code now for handling the response. And for now, let's just console log out this.response so we can check that everything works. Now, at the moment, this is just creating the object. So we need to call XML HTTP open method. We need to specify that it's going to be a GET request. We need to pass in the URL variable that we've created, and we need to pass true as well. And finally, XML HTTP.send is going to dispatch the HTTP request. Finally, we are inside the relevant folder in our terminal, as you can see, and it's very easy to start a basic web server using PHP. So I'm running php-s, and we're running that on localhost port 8000. So if we head to localhost port 8000, let's just reload the page. So you can see the initial HTTP request, which is going to pick up index.html automatically. Then we can see an XHR or XML HTTP request to data.json. And we can see that that's going to return a JSON response. The next thing our lab does is it binds the response to a variable. So we can say my obj, in fact, let's say let my obj equals this dot response. And it actually does this with the eval function, as we'll go on to see. Let's just take a look at this code outside of the eval function first. Let my obj equals this dot response. Now, what is this dot response? It's a JSON object, right? No, it's not. It's a string. Sometimes we forget this because, especially in the world of JavaScript frameworks and promises, we sometimes find that the framework actually passes a JSON response into an object for us. Whereas that's not the case with these XHR requests. This is actually a string. And we can prove this because we can actually console log type of this response. We say type of this dot response. Let's see what the output gives us. We'll head to the console. So we can first of all see it echoed out, type string. So this is not an object, at least not yet. The correct way of handling this is to make use of JavaScript's JSON.parse method. So if I do let my obj equals JSON.parse and then put this response as the parameter. Now if we console log out type of my obj after it's been parsed as JSON, let's check this out. We can see we get object. We can actually now use that object to reflect data to the page. So just as a quick recap on our JSON object, it's returning information as the key and then Zen shell as the value. So we could do something like document.getElementById. We created a paragraph and we gave it the ID of page. So let's just pass in page. That's going to select that specific element from the DOM. Then we can set inner text equals my obj.information. So that should now render the data to the DOM in response to that HTTP request where we get the JSON object returned. So let's head to our page. Let's refresh that. We can see we get the information rendered to the DOM. As mentioned, the exploit actually happens before this. Now let's head to our JSON object. Now we don't need to worry about escaping or anything like that because we actually have direct control over the JSON object. That's the difference in the lab is we submitted that AJAX HTTP request and there was some escaping going on with the response. Whereas we can control directly that JSON response. We have it here in this file. So we're one step ahead compared to where we were in the lab. We can think about this exploit without needing to worry about any of the extra complexity that comes from escaping. So what we actually had is we had a string and we had minus alert function. Now notice straight away that that is linted in red. It's indicating to us that this is not actually a valid JSON object. I'll see what happens when we try and run that. What do you think? Are we going to get the alert echo to the page? See what we get. We refresh that. We get an error in the console. Uncaught syntax error. JSON.parse expected a comma or the end of the object. In other words, it's saying we can't run JSON parse method on this JSON because it's not valid JSON. Why is it not valid JSON? Sometimes we think about JavaScript objects and JSON as being the same, and they're actually not the same. They're similar, but they're different. They have different rules. In fact, take a look at this section. JSON evaluates to JavaScript objects. The JSON format is almost identical to JavaScript objects. In JSON, keys must be strings written with double quotes. So there's one difference right off the bat. You can see JSON, you have to have the key inside double quotes, whereas JavaScript, you can just do this. We don't care about the double quotes. But then if we take a look at the values as well, in JSON, values must be one of the following data types: a string, a number, an object, an array, a boolean. I don't see anything to do with like a function or a method or anything like that. That's not valid JSON syntax. You can't have an expression or a function in JSON. It has to be a string, a number, an object, an array, or a boolean. That's it. In JavaScript, however, values can be all of the above plus any other valid JavaScript expression, including a function, including a date, including undefined, including Zen shell minus alert method. That's a valid JavaScript object as well. It's just not valid JSON. So this is why when we're calling JSON.parse, JavaScript's refusing to parse it. It's saying this is not a valid JSON object. And here is where we get back to the problems with eval. Let's now rewrite this single line of code using eval instead of json.parse. So we're going to use eval. And remember, the idea behind eval is it takes a string as a parameter, and then it reads that string like it's JavaScript. The key problem here is that it's very easy to inject into strings, and also we're not making use of json.parse. We're not checking if this is a valid JSON object before initiating it into a JavaScript object. So it's essentially the same line of code, but it's inside a string. So we're going to say let myObj equals, and we're simply going to concatenate to that the response that we get back from the server, which is that data.json file. But remember, it's not a JSON object yet, it's just a string. Yes, it's JSON, but it's in string format. So that's why we can concatenate it here. So we'll say plus, and then we'll say this.response, and we're going to comment out the correct line of code. So this is very similar, but remember, this is actually jumping straight into a JavaScript object, taking a string and it's using it to create a JavaScript object. It's completely bypassing that json.parse section where we check to see if that is valid JSON. And remember, if it's valid JSON, then we can't just tag a function on the end of it. We're going to get that error. The cross-site scripting attack never happens. But in terms of passing this as a string as part of the eval function, well, this is a valid JavaScript object. It's not valid JSON, but it is a valid JavaScript object. Let's see what happens now when we run this code. Refresh the page. Now we get the alert popped up to the page. Now, one of the subtleties of this lab is we might imagine when first solving the lab that the cross-site scripting attack occurs when information is rendered to the DOM. Whereas in fact, it's this line that triggers the cross-site scripting attack. In fact, the rendering to the DOM doesn't even work unless we actually use var myObj instead of let myObj. So if we actually run this attack now, you'll see that the attack succeeds. We get the alert. Then when we click OK, we see NAN rendered to the DOM. And the reason why we have NAN, it's just to do with the dynamic typing in JavaScript. It's trying to assume that this is a type integer when it's not. So it's just saying, actually, this is not returning a number. So we're getting NAN. If we actually remove this and refresh the page, of course, we don't get the cross-site scripting anymore, but we see the rendering to the DOM occur correctly as we'd expect. But there's obviously now a vulnerability with this lab, which is we just manipulate the JSON response. So we're doing it directly on the JSON object. In the lab, we do this via the search input. We obviously need to consider escaping when we do that. And you see very clearly we get the alert and then we get the rendering to the DOM. In fact, if we just completely remove the rendering to the DOM, but let's just do absolutely nothing after that eval function is called. Let's refresh the page. We get the alert popped up to the page still, no rendering to the DOM. So unlike other types of attack where maybe the cross-site scripting vulnerability occurs after the rendering to the DOM, in this case, we can see it actually takes place beforehand, and it's to do with the use of that eval function. So the key takeaways, anytime you see eval being used as part of the JavaScript, that's a big red flag. And the reason why is because eval takes in a string and it's very easy to inject into a string. And the chances of being able to run arbitrary code when eval is used on the JavaScript is much higher. We also saw how removing eval completely fixed the cross-site scripting vulnerability because we weren't even able to parse that JSON object because JSON parse could see it was corrupted. It wasn't valid syntax. It wouldn't even begin working with that object in the first place. Eval doesn't care. It just takes in the string and doesn't care how that string's been injected into. It will try and use it as valid JavaScript.